Hey everyone, I'm Lakshmi Priya doing an integrated MBA and MS in Technical Entrepreneurship, and in this course I'm going to walk you through the basics of semiconductor, and this course is for IIT JEE and 12 CBSE students. So this is the course overview, and in this course we're going to say what is a semiconductor, types of semiconductor, and different semiconductor devices. We have 2-terminal device, 3-terminal device, and a 4-terminal semiconductor device. Under 2-terminal semiconductor devices, we'll be learning on the working of diodes, forward and reverse bias, and types of diodes. Under 3-terminal device, we'll be learning on the working of transistors and different types of transistors that exist today. And under 4-terminal semiconductor device, we'll look into specifically 2 examples, a photocoupler and a half-effect sensor. Finally, we'll also see the applications of all these semiconductor devices in real life. Don't worry, this is not as hard as a topic as you think. This is more like a story, so let's go learning slowly from the basics. Now here I have a battery, a circuit, a bulb, and a gap. When I fill this gap with a material such as a paperclip or any metal for that matter, the light turns on because the metal over here acts as a conductor to electricity. When I fill the same gap with some other material like plastic toy or wood, the light doesn't turn on because this material acts as an insulator to electricity. When I fill the gap with a semiconductor material such as silicon wafer, the light doesn't turn on at room temperature. However, when I heat the silicon wafer, the light turns on. How does this happen? This is because atoms of each element occupy specific energy levels at room temperature. When there is multiple atom interaction, their energy levels tend to shift around. What happens here is that when I supply external energy in the form of heat, light, or electric field, the electrons in the lower energy state gain these external energy and get excited and jump to higher energy states. The distance between the lower energy level and the higher energy level is called as the band gap. Thus, depending upon the amount of external energy that's being supplied and the band gap determines whether the material is a conductor, semiconductor, or an insulator. For an insulator, the band gap is so high that a lot of external energy is required to excite these electrons at lower energy state to jump to higher energy states. Usually, materials that have greater than 3 electron volts of band gap is said to act as insulators, like in case of this glass bottle. For a conductor, there is no band gap at all. Their energy levels tend to overlap with each other, making it very easy for the electrons in lower energy state to jump to higher energy states. Materials that have 0 electron volts of band gap are said to act as conductors. For a semiconductor, the band gap is definitely smaller than that of an insulator and greater than that of a conductor. So some amount of external energy is required to excite these electrons from lower energy state to higher energy states. Usually, materials that have less than 3 electron volts and greater than 0 electron volts of band gap are said to act as semiconductors. So where are these semiconductors being used? Semiconductors act as a perfect brain of electronic devices, and many semiconductor acts as switches called as transistors. Have you ever wondered that the laptop we use are made up of millions of switches? And this is one of the reasons why the laptops are able to do math and run complicated programs in them. Now we need to build a device that's able to switch between conduction and insulation. However, we don't want a mechanical switch where we can go switch it on and off every time. So let's take a quick look at how semiconductor devices were built in ancient days. So this is a device that we have to build, which acts as a conductor in one direction and insulator in another direction. If we are successfully able to build such a device, then we can go ahead building lots of computers. So this is a picture of how semiconductor devices looked in olden days. It was able to conduct in one direction and act as insulator in the other direction. But look at the size of these semiconductor devices. So think if we have to put in millions of these semiconductor devices to make a computer, then what's the size of a computer? You have to fit so many computers in different rooms. Even if you have to compute a small program or small function like 1 plus 1, you have to give the input in one room and go and search of the output in another room. Luckily, the semiconductors that we use today are very small, like you can put in a billion of semiconductor switches in your fingernails. Now, this is one of the standard semiconductors that we use today. It's slightly bigger. The size is about 4 millimeters. This is actually a two-terminal semiconductor device, which we will be learning further in the following videos. So this black area is called as the anode, and this area acts as a cathode to the semiconductor. So the semiconductors also make up the logic elements, memory components, and communication module. And this is the reason why computers are able to interact with each other, and they have brought in all the industrial revolution that we know today, like mobile phones, laptops, PCs, IoT, and a lot more. So if there's no semiconductor device, then there's no information age. So long story short, in this video, we learned about the basics of a conductor, semiconductor, and an insulator. We also took a quick peek on how semiconductors were built in ancient days. So in the next video, we will be learning on the different semiconductors that exist. Well, thank you for watching, and if you have any queries, you can storm in the comment section below. Stay tuned for more.